Welcome to qnawire.
Hi, so in this question, since we have already solved the first part, I'm going to focus on the second one using the data from the table. And we need to calculate delta G, delta H, and delta S for the reaction of sulfur plus oxygen in order to produce SO2. So in this case, the delta G for the reaction is going to be equal to the delta G of formation standard of SO2 plus minus delta G of formation of sulfur minus delta G of formation of oxygen as a gas. Replacing the values in terms of delta G, the formation of SO2 is equal to minus 300.1 kilojoules per mole, minus delta G for sulfur. In this case, it's going to be 236.7. And in the case of oxygen is going to be a nice zero. So the result over here is going to be minus 536.8 kilojoules. So this would be the value that we need to plug in here, minus 536.8 kilojoules. Now for delta H of the reaction, the procedure is going to be the same. Actually, let me just reuse this part over here. The only thing that is going to change for us is going to be the delta. Instead of delta G's, we're going to plug in here delta H, and the signs and everything else is going to stay the same. So the standard delta H of the reaction is going to be equal to the delta H standard of formation of SO2 minus delta H standard of formation of sulfur minus delta H standard of formation of oxygen. So with this, of course, the values are going to change as well. In this case, now this is going to be equal to, for SO2, we're going to get a delta H of formation of minus 296.8 kilojoules per mole, but we're multiplying by 1 mole of reagent because of the reaction that we have, minus delta H of formation for sulfur, which is 277.2 minus 0. So we're going to end up with minus 296.8 minus 277.2 minus 574 kilojoules. In this case, we should plug in here minus 574.0 if we want to be consistent with the number of significant figures that we're going to get. And finally, for delta S, the procedure is also going to be the same, but again, the only thing that changes is the label that we're going to employ. So let me erase this part. The delta H of formation that we had here and here now are going to change up a bit. And instead of delta H of formations, redraw this minus sign just to make it a little bit prettier. Now we're going to have the value for S naughts. The standard entropy for SO2 minus the standard entropy for sulfur minus the standard entropy for oxygen. And of course, here would be change of delta S for my reaction. So now delta S standard for the reaction would be equal to 248.2 minus 167.8 minus 205. We get that the delta S for my reaction would be, now this is going to be in joule per Kelvin directly. We're going to get minus 124.6 joule per Kelvin. Minus 124.6 joule per Kelvin. So what this means is that delta G is going to be negative under standard conditions, but since we know that delta H is lower than 0 and delta S is also lower than 0, that means that the reaction is going to be spontaneous at low temperatures. Why is that? If we look at the value for delta G, which is delta H minus T delta S. If this value is lower than 0 and this guy is lower than 0, that means that this factor is going to become larger than 0. And the larger it is, as temperature increases, the less spontaneous the reaction becomes. So over here, the reaction is going to be spontaneous only at low temperatures. So that would be all. Thank you very much and have a good one.